Hello everyone, welcome to Module 2. This topic is about supply chain management information systems. During Module 1, we talk about the importance of flow, how materials and information should be flowing. This Module 2, we are going to talk about the technological enablers that facilitate such flows. So let us start. So at the end of this module, you will learn, first of all, to distinguish data from information. Second, to describe the characteristics used to evaluate the quality of data. Number 3, to identify the value-added processes in the supply chain and describe the role of information systems within them. So we're going to be talking about the common softwares and packages that nowadays exist to support the supply chain. So let us start with technology infrastructure. Well, it includes not just the hardware and the software. It's also about databases. It's about networks, internet, for example. It's also about the people, the procedures, the policies behind. So in order to collect, manipulate, store, and process data into information by means of knowledge. So once again, here we have 3 words, or keywords, better to say: data, information, and knowledge. Now, just to clarify, hardware consists of computer equipment used to perform input, processing, and output activities. Software, well, no, I mean, these are, I still wonder if you know what that is. This used to be the 3.5 inches diskettes. I used those as a student back in the 90s. So software used to come in this form. So you were supposed to even upload Microsoft DOS system even before using a computer. I mean, those were really crazy times. But the principle remains the same. Software consists of the computer programs that govern the operation of the computer, basically. We also have databases, which is a collection of facts and information. And well, it typically consists of 2 or more related data files. So that's what we can call a database. Okay, so let us start with the concept of data. Okay, so data can come in all sort of forms, flavors, and colors. It can be alphanumerical, it can be image, audio data, video data, right? So this presentation, this video lesson is audio and video. Alphanumerical data, well, I think alphanumeric, and that means letters and numbers. So numbers, letters, other characters. Well, nothing else to add, but maybe here the question that you're asking, okay, so what is the difference between data and information? And I have an example for that. I want you to have a look at this picture and to think. I mean, normally I would ask you in the classroom, what do you see? But okay, I cannot listen to you, I cannot read your thoughts. So I want to believe that you're thinking about this question. What do you see here? And I want to believe that you see something more than just a device, an object. You see more than just the, 28, 29 degrees Celsius, I suppose. You see more than that. You see, data has a particular meaning within a particular context. So when you look at this thermometer, the information that you derive is, hey, it's a nice weather, it's a nice temperature, it's not so hot, like 40, like where I'm coming from, Monterrey. This is a normal temperature every summer. And believe me, it's not nice. We don't like to be laying on the sun as people here in Europe. We always look for the shadow. It's also not minus, as I don't know, maybe some places from Scandinavia. It's a nice temperature. So you are even you're deriving information, and then you're even applying maybe knowledge, because with this information, you can already think about the clothes you need to wear, etc., etc. Okay, so information is a collection of facts, and we need to have a context. Okay, so here's just a zoom. So what is with knowledge? Well, there is a transformation process from data into information, and we apply knowledge by: one is to classify things. For example, placing data into categories. Which categories? I don't know, it depends on the context. It could be target groups of people. It could be tangible, intangible. It could be colors. It could be level of importance, values. We also apply knowledge whenever we want to sort, because if we're talking about a hierarchy of values, we want to distinguish those from the highest to the lowest, perhaps. So it's about organizing. It's about aggregating, calculating, so selecting. And here I'm missing aggregation description, but what it means is collecting items all together. That is aggregating. As in business would be, in supply chain context would be a forecast, a demand forecast. A demand forecast for bicycles. We don't forecast by means of mountain bikes or road bikes, we just forecast by bicycles. And then of course, we can calculate based on data, especially if that is numerical, and then we can select items of that data based on a certain criteria of importance. Okay, so data is about raw facts. Information is about the collection of those facts, which is organized in such a way that have value we can interpret beyond the fact themselves. And knowledge is an awareness, an understanding of a set of information. So I hope these three basic terms now are clear to you. So let us just have a quick look, and here what you see is the outbreak of a virus. I think you know which one it is. And these are two different sources. So this is the German-Chinese Bureau of Economic Research. That is the link if you want to visit that. And this one here is the National Health Commission of the People's Republic of China and various international media. So you see they both share that they are Chinese, yet the information provided is a bit different. By the way, when I took this snapshot, you can see here it was on the same date and on the same time. Nevertheless, the data reported was different. And yeah, I can imagine what you're going to say. Well, it's just about, it's a small deviation of 15 cases. But still, how come this data, how come this data show a level of a gap? How come it is not equal? That is one of the questions I ask myself as well. So what makes information good? How can we characterize, how can we evaluate the quality of such information? Well, there is a list of characteristics, and we can quickly review them here. There will be a table, but let's just go one by one and kind of quickly. So first of all, we can characterize the information by how accessible it is. Information should be easily accessible by authorized users. So in the business context, you have an authorization based on job positions, on roles. So certain people can access certain information and some not. Of course, it has to be accurate, error-free. In some cases, inaccurate information is generated because inaccurate data is fed. This is what is known as garbage in, garbage out. I think you have heard about that. Very common in business, very common in supply chain. One particular example comes to my mind at this moment, inventory records. On-hand inventory records. How many items of a specific SKU, a part number, are we having in our warehouse? You go to the computer, you have a report from the information system, there is a certain number, you go physically there and surprise, surprise, the number is different. Okay, so there is a deviation. Why is that? It could be due to all sort of reasons. Information should be complete. The thing is, that is quite obvious. Economical. Information should also be relatively economical to produce. Think about business KPIs. I mean, maybe people, managers like to monitor all sort of aspects in business, but it costs a lot of manpower to do that. So you have to prioritize, to give different weight or value to what is important, because it consumes resources to generate data. Information should be flexible. It can be used for a variety of purposes. Think about for demand forecast. Demand forecast can be used not only for operations, for planning how many items and which items need to be produced when, but it can also be used by human resources for manpower, headcount calculations, for finance as well, etc., etc. So it's a flexible type of information. It should be relevant. It measures what matters to be measured. It's reliable. We can trust. Yeah. If you don't have operational discipline on your operations, if the collection of data happens, is out of control, like an employee reading barcodes with a barcode reader every time goods arrive from the supplier, if that operation is not under control, your data is going to be completely off reality. Yeah. It has to be secure, a big topic nowadays about privacy and how to control that. So we don't want unauthorized users, not to mention hackers or even the competition, to access that information. You can imagine how difficult that is, no? I mean, you have heard the scandals behind Yahoo.com, for example, in which a lot of accounts were compromised. I think Sony PlayStation had the same situation. Information should be simple. You don't want to overly make it complex. You want to quickly assess what matters, and so that you can apply your knowledge. It should be timely, should arrive on time when you need it, not too late, because then why would you need that? So if you're monitoring your sales force and you want to know how much you're selling in a given territory and by a given group of individuals, you want to know that, if possible, on real time. You don't want to receive sales reports from last month. I mean, you cannot take strategic decisions. And of course, it should be verifiable, because that means that you can check it to make sure it is correct. So we want to validate it. So we can check it by, for sure, other sources. So we can always validate that information. So you see, we have a long list of characteristics, and believe me, not always every information in business complies with this list. Okay, so the components of an information system are basically inputs, outputs, and processing. And maybe what is important to emphasize is that this process of collecting data and processing this data is not always computerized. Here, this is a case, an example. These charts that you see, these are run charts. They monitor the performance of a particular process. So these are the so-called SPC charts, statistical process control charts, right? And you have very sophisticated and fancy applications as the one you can see here, but sometimes it is collected as what you see here, manually. Now, don't be surprised that sometimes this manual process is more reliable than the automatic process. So very often in business, in manufacturing, a lot of data gets created manually. Okay, so here's just a more practical example from a supermarket. So you can see the transformation by means of a system. So on the left side, you have raw data, and the right side, you have information. So left side, what do you see here? A bunch of numbers, codes, I guess, a list of items like Bright Dish soap, BL Hill coffee, Meow cat. I wonder what that is. I guess, what can that be? I suppose cat food. And then again, bright dish soap and country ham and fiery mustard, I guess that is very spicy. And eventually, thanks to the information system, data gets transformed into reports. So you can analyze and apply knowledge, because you can say, hey, in the sales region Northwest, in that particular store, number 122, we have 7,156 units sold of bright dish soap, which is this SKU number or item number. And we can also derive even yearly sales and so on. So these are the so-called reports. So raw data gets transformed into reports, and these reports very often, I mean, you can buy them already pre-made, so to say, or if you have IT people in your company, you can request them to create the reports of your wish, or you can just outsource that task also. Doesn't matter. So you want to extract what matters to you. Okay, so going back to information systems. So information systems is basically it's a process of inputs and outputs in which data get collected out of some kind of like small databases, as you can see here. This, by the way, this representation of a cylinder represents a database. So in this case, we have an order processing system that is collecting orders. We have a materials resource planning system. These are the MRP or ERP, like maybe you have heard about SAP or JD Edwards. So you have a production master file, or you can also have a general ledger system in which all the accounting and all these transactions goes here. And out of all these systems, you're feeding the so-called management information systems that eventually become transformed into, well, readable reports by managers. So all in all, it's just a process in which data gets collected by means of databases. It gets transformed into information that eventually will be readable and it can be interpreted by humans. Okay, so here's just a more particular case because this course is about supply chain. So a typical information system would be the one that controls stock or inventory. So you have your MRP system, your resource planning system, represented here by this box. That system relies on a database, which we can call the inventory master file. Just picture, I don't know, maybe like an Excel sheet, where you will have in one column the item code and the description of that item, how many units you are supposed to be having on hand, that means on the warehouse, and maybe also the reorder points. The reorder points, if you don't know, this means the quantity at which you are supposed to order. So if you have 10 items and these are being consumed and you reach to 4, maybe that is the reorder point in which you need to grab that phone and trigger that order to your supplier. Yeah, so here we have a connection of online queries where we can search for particular items. And again, once again, we can have reports. This is how an inventory status report might look like. So we have a list of items, descriptions, on hands, how many of those are on order, you see here with Power Chord, on order higher than what we're having on hand, so that we can apply knowledge. We can trigger an order to our suppliers of replenishment. So all these systems that I'm describing, I mean, they don't come just like automatic per se. Very often there is an evolution in which organizations started to create their own systems. Sometimes these systems are just Excels, spreadsheets. For example, at my university, we receive a lot of spreadsheets all over the place, like for final presentations, for exams, and to be honest, it's kind of complicated because all this flow of information goes through email. So there is a so-called capability maturity model. I think it's important that you have that in mind, that defines certain levels. So level 1 is that level that I just described. It's the initial level. It's an organization, an information system that is very immature, chaotic, informal spreadsheets that, you know, sometimes people are having different versions of that, and of course with different information. Eventually, that organization can move into a level 2. So now things are becoming more stable, more repeatable. So now you have certain formality of processes. So now you have maybe some flow charts that are visible and transparent to everyone. So everybody has, how can I say, an understanding of how the workflow is happening. Level 3 is about definition. So now this is a higher level of standardization. So now, you know, you have a higher level of control, and now you are implementing best-in-class software. So now, forget about creating our own solutions by means of Excel. Now we are integrating applications and already made solutions. Level 4 is about capability, it's about maturity. Now everything is running very smoothly. Everything is becoming more integrated. A certain decision, you can see the impact of that decision on different reports. Eventually, the highest level is highly efficiency. Is the level in which you are just tweaking and optimizing. I mean, we're talking about processes that are highly reliable, highly standardized, very repeatable, very under control. What kind of organizations can you think that fulfills these requirements? I don't know. I guess since I am at home, I can think about Amazon, Amazon.com, Amazon.de, with the distribution partners that they have with DHL, for example. I mean, all these companies, they are on a very high level of control of what they're doing, and they're just optimizing, they're becoming faster and more responsive, etc. Thinking about the supply chain of toilet paper, well, I don't know. I mean, that is a good question. What kind of level would that chain would belong to? Maybe it's not in that level 5 already. Otherwise, we wouldn't face this scarcity. I mean, for, let's say, a long period of time. And let's keep that as an open question. Okay, so information systems exist along the supply chain. Here is a scheme, a high-level scheme in the center. We have a factory. On the left side, we have all the sources channels. On the right side, we have the distribution part. And here we have a series of boxes. And they are all acronyms with 3-letter acronyms. And they stand always for a meaning. And I have a better picture now that I realize, which is this one. And I will explain it more in detail. So let us start with the upstream management part, and that is the supply side. So here there is a material flow, the raw materials are flowing, the inbound logistics, and the warehouse and storage. This is our company receiving these trucks. Yeah, we produce, we extract those raw materials from our storage, we produce them. So we have a department called production control. That is a department that deals with the communication with our suppliers, the communication of the shop floor, and the communication with the next part, the demand side, because goods, finished goods, have to be also stored, distributed by a network, and eventually there is the after sales and all sort of services attached. So this is the typical importers, Michael Porter's language. That would be the core process of the business. So we have here the upstream management, source, make, deliver. Now you also see here a small description of all sort of tracking systems and control systems. Those are those boxes that I showed you before. So we have the transportation management system, which occurs not only here but also here, because we want to control which trucks from which suppliers are arriving when. Yeah, and we want to create a schedule because we need to organize this docks that you see here, these doors. So I know by fact that some suppliers are very strict. I mean, if this would be Metro and you're receiving a truck of Coca-Cola and it's supposed to dispatch those Coca-Colas at a specific date and time, and this door is not available, then you for sure you will have to pay a fine, and that is based on the time that truck is waiting. Okay, so we have these transportation management systems. We have also warehouse management systems and labor management systems, because we have to manage people, we have to manage all sort of activities inside of our warehouse, and that happens not only for items, raw materials store, but also the finished goods stores, and also, I have to say, the work in progress, the stock that you have under production. Yeah. So all these activities are integrated by a system called ERP, or Enterprise Resource Planning. So this is like the, how do you say, the hub, or it's a modular system. So this is the platform that holds all these peripherals. We also have a peripheral called Supplier Relationship Management, and this interacts with our suppliers. And we also have the CRM, which is Customer Relationship Management, that collects data from our customers in all sort of forms. It could be that these systems are integrated with the supplier's ERP and the customer's ERP systems, because they have also their own, and of course they have their own applications such as warehouse management systems and transportation management systems, etc., etc. So as you can see, we have this multi-site integration of ERP systems. So in theory, it's very nice and very beautiful, just like this slide that I prepared for you. But of course, in real life, it's way more complex, way more messy. You have to picture a lot of these companies, they use different packages and different softwares, and data has to migrate from one to the other. And sometimes you need other packages to glue these systems. So it's a really a big headache. Huh? Okay, so in short, information management systems can help firms first to decide when and what to produce or store, to communicate orders, to track the status of orders, to check the inventory availability, monitor inventory level, track shipments, plan production based on customer demand, and this is a data that you need to collect from the point of sales, from the stores, from the retailers, and of course to communicate rapidly to the changes in product design. Hey, you launch a product and there are some defects, some customers are complaining about something, you need to collect that, provide that information to your team that is behind the product design, and quickly implement that design, produce it, test it, and deploy it. Some companies really excel in this speed. I mean, think about Zara, for example. It takes Zara around 2 weeks from conception to that product to be on the store. 2 weeks. That is really impressive. Okay, so an example of supply chain management system is represented by this the drawing here, and you can see once again we have a warehouse management system and a transportation management system that are in communication with distribution centers and freight carriers. These are external companies. And then you have a series of communication, very specific, like plans, orders, shipments. These are documents, but of course these are digital documents. And the way these digital documents are flowing are not by emails, not at all. These are documents that get codified and transformed into some kind of language that we as humans cannot really read it, and then get decodified again. So you have a lot of flow. The invoices are flowing, and etc. Shipping notifications. So that eventually we can rely on the systems that I explained before, and of course visualize the status quo by means of reports. Maybe here we have here this so-called middleware in this green circle. Middleware is a software that glues. It's a software glue that glues all these systems together. Again, as I explained, because very often these applications are from different providers. Yeah, it could be that you just buy the full package from SAP, but sometimes it's not the case. Another perspective, and this is we're almost done here, is the following. You can see systems from strategic, tactical, and operational applications. So strategic are these long-term type of decisions, such as supply chain design. So you're not designing your network on a daily basis, not even on a monthly basis. You design it every 5 years or so. You have to develop suppliers, etc. Then you have, of course, a medium term in which you are collecting demand forecast, and you are integrated, and maybe this is for 180 days, 90 days. You integrate it into your system. Then you start planning your resources, which items need to be produced and when, which items need to be procured and when. So this is a medium term. So here you have your master production planning and demand planning aspects. That is, by the way, product life cycle management. And then, of course, you have the daily operation, the short-term level. So now you're really executing. This is the daily activities, the e-fulfillment at Amazon, for example, the warehouse management, movement of goods, the material movement. So everything is enabled by an IT integration of all these systems. So this pyramid is just another perspective of what I just showed you before, but now from the perspective of time. These are decisions taken during different time frames, yet everything has to be aligned and connected. Okay, so lastly, it's not enough to reach to success by means of pure technology or information systems. We need to integrate other aspects. We need to integrate people. We need to integrate organizations which also have their own particular culture and values. So all these components have to be taken into consideration as to ensure a success of an information system. So as you can see, it's a holistic approach. Nothing else to add. That is just an insight. We will explore more later on in the next modules. What is behind this warehouse management system? What kind of operations, like the picking process, what kind of technologies exist nowadays and are in the pipeline to come? Which kind of technologies exist for delivering, for example, during the first mile or the last mile? And tons of exciting things are yet to come. Thank you very much for your attention, and until the next module. Bye-bye.